In this specific lecture, we're going to take a look at when our output, so our new child tag, actually has too much weight in it to be able to justify that amount of product was the actual amount of output volume. So let's use another whiteboarding session and dive into exactly what I mean here. Okay, so let's build off of the example from the previous lecture. So we're going to start from the top, and we have 3 packages with 1,000 grams in each. Again, these are trim packages. And then from these 3 packages with 3,000 grams, we then make a batch of crude oil with 450 grams of hash. And this is our new child tag. And we also have a 15% yield. With these 450 grams of hash, we're going to make a new product, and that new final form product is an inhaler. And that inhaler includes 1 gram of hash and some terpenes, but those terpenes were natural terpenes that we infused, so it's not count against the concentration limit. Theoretically, with 450 grams, and if we're going to make a new product with 1 gram of hash per inhaler, then the new amount of units that we are going to create in this assembly theoretically shouldn't be able to exceed 450 units, because 1 unit equals 1 gram. And actually, because of processing loss, because we might weigh heavy, because of all of these different things, I would not expect to receive 450 units from this production batch of 450 grams. That just wouldn't be possible. And so the right flow here would be to, let's say we create another tag and maybe we got 400 units. So then we do that conversion from grams to each. And then we create another new, and we have another new child tag at this level. And then in addition here, what we would also do is, of course, from this tag right here, we would also do a negative 50 gram adjustment for waste. So that way there is no weight left in that intermediate tag between our trim packages to our final form units. And then we're only moving in our final form units into our new child tag. Another great best practice from RMCC is when you create a new child tag, you really don't want to do any adjustments in that new child tag. You want to save the adjustments for the previous step. And that's because you are creating a new tag. So theoretically, that should be as close to perfect as possible. So we only want to decrement 400 grams from this intermediate tag and move those 400 grams and convert them to an each unit of measure to say we now have 400 eaches of 1 gram inhalers with terpenes. So that is the proper flow. Let's look at some examples that I have seen in many audits that have happened in the past. So this is going to be the bad example. Again, our intermediate tag is 450 grams. And then somehow I actually made 800 units of 1 gram inhalers. And when we go to create the COA test and the test results come back, and the actual units of these 800 units actually did have a potency of 1 gram THC in each unit. And as we can see, we can't have 450 grams right here and make 800 units with 1 gram. So this tells me somewhere right here, when we pulled in our intermediate tags to create these final form unit tags, we missed a tag somewhere. So somewhere there's more ghost weight in the crude oil level, potentially, or this could be compounding at the trim level as well. But essentially somewhere we missed a package to be able to input that into our assembly for us to have a output of 800 units with 1 gram in each unit. Now, how are you going to identify these errors within your metric? It's all going to go back to your production log and how well you're creating those records and auditing those records and validating that against your metric records. These type of assembly errors are very hard to identify. Within metric, you can really only see it when you drop down the history of the tag and go down the rabbit hole and go tag by tag. So the more operational framework that you can implement into your business and actually validate and audit that data, the easier it will be to identify these conversion errors and get ahead of them before they become a problem.